Hey, all you crazy cats and kittens. It is time for us to start our next chapter, which is on energy. And energy, if we think about it, if someone has a lot of energy or if someone doesn't have a lot of energy, that's something that we can actually see, and it doesn't take us too long to figure that out. But we can also say the same thing when it comes to objects. So, energy, by definition, is the ability to do work or ability to cause motion. And if we think about that people example, someone that does have a lot of energy, typically you can see that they get up early, they are active. Someone that doesn't have a lot of energy, they might be bigger or they might just be sitting around kind of couch potato, and it takes more to get them moving. And so, what we have to understand is that energy actually does have a formula, and it's based on a lot of different things. So, if we go back to looking at, so first of all, the unit of energy is called a joule, spelled Joules, and it's a capital letter J. But if we go back when we talked about Newton, that was a kilogram per meter per second squared. So it looked at the mass of the object and how fast it was going. What we're looking at with a joule is we're actually also taking a look at another unit of distance. So if we look at the overall, what a joule is, it's a kilogram, so it takes into consideration the size of the object and how fast it is going or how fast it goes over a certain amount of time. And so, energy, in short, is the ability to do work. Some objects can do work more easily than others and can be caused to do motion more easily than others. So, let's talk about the different kinds of energy that are out there. And that's what our presentation for this slideshow is about. The first type that we want to talk about are the two main types we call potential versus kinetic. So potential energy, if someone has a lot of potential, it means that they have the capability or it has the ability to move. Now, sometimes things or objects don't live up to their potential, and so that's why we have that word in front of the energy. So there are two different kinds of potential energy. The first type is what we call elastic, and that is where energy is from compressing something. So we see this if you look at with the bow and arrow. The most potential energy is when the arrow is notched and pulled back. With a spring, with a slingshot, those are types what we call elastic type of energy. Another one that we see could also be a golf ball. So if you've ever seen a slow motion video of a golf ball being hit, it actually flexes slightly as it's getting hit by the driver, the 3-wood, or whatever we're hitting it with. And that's what we call elastic energy. The best golf balls are those that are a combination of, yes, a hard outer part, but also a lot of flexion so that it bounces off the club head that much better. So that's what we call elastic energy. And that's the one of the first types of potential. The second type of potential energy is based on gravity. Now, this one we have talked about quite a bit. If I have, let's say I'm on top of a diving board and I have a golf ball, we'll stick with the golf here, a golf ball versus a bowling ball, and I ask if they're held at the same height, which one has more potential energy? What would be your answer? Hopefully, it would be the bowling ball. Why? Because the bowling ball, even though they're at the same height, even though they're at the same gravity, it has more mass. And so, one of the ways that we kind of talked about this earlier in class is that think about what object would cause more damage when it falls. And so, obviously, the bowling ball would hurt more than getting hit by a golf ball. Let's say if we're at 6 feet, the bowling ball might knock you out. A golf ball might cause you to, get a notch in your head or something like that. So, when we look at this equation wise, it's called gravitational potential energy. So it takes into consideration how big the object is or its mass, the gravity. Now for us, it's going to be a constant here on Earth at 9.8 meters per second squared, and then the height that it would potentially be dropped off at. So all of those things considered are part of the gravitational potential energy equation. Now let's get into actual movement, or what we refer to as kinetic energy. Now, what's unique about kinetic energy is that this is where the object is actually moving. And just like potential energy, there is a formula. And what it looks at is it looks at the object's mass, although it doesn't take into consideration the entire, notice that it's 0.5, and then how fast it's going. So still, we are talking about joules here. That is the unit of energy. So if we talk about a cheetah, so 44 kilogram cheetah running at 31 meters per second. And so the equation would look like this. We would take the mass of the cheetah, half of it, and then we multiply it by 31 meters per second, but we're squaring that. So 31 times 31 is 916. So what we're doing is we're basically taking 22 times 916, and we would get 21,142 joules. All right, so that's the equation. Now, if we look at it, kind of go back one, so the potential energy took a look at mass, gravity, height. If we look at the kinetic energy, it's taking a look at mass, but here we don't have to deal with height or acceleration, but we are dealing with velocity. So we're still dealing with a speed, and that's why the same unit is being used. So kinetic energy is the energy of the object when it's actually in motion. The amount of energy depends on how big it is and how fast it's going. So if we go back, we're talking about bowling quite a bit here, but let's say that we're a bowler and we use a 12-pound ball versus a 20-pound ball. They are going to carry with it different amounts of energy if we throw it at the same speed. Why? Because the mass is different. Can we get a 15-pound and a 20-pound bowling ball to have the same kinetic energy? Absolutely. This goes back to Newton's second law. I would just need to throw that lighter ball faster. I would need to throw the more massive ball slower, and they would get the same energy because we can change the speed that it's going, and we know that the ball would be then different mass. So those are two main types of energy. Very important for us to know. Potential, the ability or capability of moving. Kinetic is when it's actually moving. Now let's start to get into the different kinds of energy. And this is a review of what you had in 6th grade, and also we did this a little bit in 8th grade. So the 7 types of energy include mechanical, chemical, electrical, nuclear, thermal, radiant, and sound. Most of these we talked about in 8th grade, but some of them are going to be introduced because we're obviously adding to our knowledge that we've had. So let's dive into these. The most common one is mechanical energy. When we think of this kind of energy, we want to think of when the object is actually moving, all right, or it's going to be moving. So mechanical kinetic energy, a moving car, a cheetah running, that bowling ball. Mechanical potential energy would be stored in a spring, a compressed ball, a plane that is in the air, meaning that it's got to come down, a pop fly. All of those things where we know it is going to move, but it just hasn't quite started that movement yet. So in short, mechanical, think movement, M&M, mechanical movement. The next one is what we use most as humans after we eat. So what we actually do when we eat food is we're trying to get chemical energy harvested from them. All of the stuff that we eat is made out of a protein, a lipid, a carbohydrate. And what our body does is once we consume the food, it tries to break it down into energy that we can actually use. Namely, it's called glucose, which is a kind of sugar. So what we're actually doing when we take food in is we are breaking the bonds of those different molecules that we are taking in. We talked about this with the different types of foods that we eat. And so that's a type of chemical energy. So don't necessarily think of that as always gasoline, although that is a great example of one. You also have batteries here that are shown in the diagram below. So yeah, those are definitely chemical energy. They're burning fuel. That's the best way to think of chemical energy, is it's burning some kind of fuel. But don't always think of just gasoline. Food is fuel. Battery acid is fuel. And when we change that fuel into actually doing something, that's chemical energy. Our next two, electrical, lives up to its name. It's the energy from electricity. Well, what is electrical energy? It's the movement of electrons, those small negative particles that are moving around in a circuit. and we can generate that energy. Someone sitting on we see this sometimes with cartoons, but someone sitting on a bike pedaling technically could generate electricity. We know that wind turbines generate electricity. We know that solar energy can generate electricity. How does it do that? Well, it either excites or causes electrons to move, and that's how we get electricity. Nuclear is something that is super, super important with the energy in our sun, as well as in nuclear energy that we get electricity from. And what's happening there, this is a relatively fancy chemistry or science, is that you're actually getting an element that is going to split its nucleus, which remember is very abnormal. And when that happens, it gives off energy, and we're able to harness that energy with using different types of radioactive isotopes. Uranium is one of the most popular kinds. Our last three that we'll talk about in class, thermal energy. So coffee thermos, thermostat, thermal socks. It deals with the energy that comes from heat or the movement of particles. How right now can you generate thermal energy? Well, just take your hands, put them together like you're clapping, and then rubbing them together as fast as you can. You can feel that as heat. We also can feel that with like a stovetop, with a grill. So thermal energy, we talked about that plenty. When we add heat to something, it's going to change the molecules and the particles of that substance. Another type is light energy, and we'll talk about that a lot in our next segment here. And that's the energy that's associated with what we call the electromagnetic spectrum or light waves. And I think I'm just going to leave that there for now. And then the last one is sound energy. So sound comes in the form of waves. And if you don't know what I'm talking about here, if you've been in your car or if you have a radio in your garage or something like that, sometime you will tune it into, let's say, 100.3, the fan, 101.3, 102.1. You're actually tuning in to a certain frequency, which is one of the properties of sound and one of the properties of waves that we will talk about momentarily. So those are the 7 types of energy. Now, in closing, I would like to talk about one other thing, and that is what we call the law of conservation of energy. And what that means is that energy can never be created or destroyed. Energy can only form from one to another. Now, before we go any further, we have to understand that that doesn't mean that energy conversions are 100% efficient, because they're not even close. Oftentimes, one of the main things that is lost in an energy conversion is what we call heat. So when we have an engine and it's running on chemical energy of gasoline, we know that, yeah, the wheels are turning, the pistons are going in the engine, but some of that energy is lost as heat. And so we'll talk a little bit about the law of conservation of energy in the next segment. But that concludes our topic for today. It was on the main types of energy. Energy does have an equation to it. It does have units. The 2 main types are potential, where you have just that potential or capability of producing movement or giving off energy. And you have kinetic, where you're actually doing something or giving off energy. And then within those kinetic energy, we have the 7 main kinds. So thanks for tuning in, and we will continue momentarily.